Welcome to this spoken tutorial on OpenModelica connectors. In this tutorial, we will learn to create a new class, open an existing class, connect different classes, build a model, and simulate the model. To record this tutorial, I am using OpenModelica version 1.11.0 and Ubuntu Linux OS 14.04. But the process demonstrated in this tutorial is identical in other OS such as Windows, Mac OS X, or Fossey OS on ARM. To practice this tutorial, you need to know about OpenModelica. The prerequisite tutorials are mentioned on our website. RLC_circuit file used in this tutorial is provided as a code files on our site. Download the files from code files link. I have already opened the OpenModelica window. Now we will discuss how to create a new model. First, we will create a new class. So, go to the File menu and select New Modelica class. Create New Modelica class window appears. In the name field, enter the name of the class which we want to create. I will enter the name as sample. In the specialization field, select the type of class you wish to create. I will choose class. Then click on OK. A new class will be created with the given name. We will learn more about classes in the upcoming tutorials. Now we will save this class. For this, right-click on sample class and click on Save. Choose an appropriate location to save this file. Let's close the sample file. Right-click on sample and select Unload. Click Yes in the confirmation dialog box that appears. Now we shall learn how to open an existing class. To open a class, go to the File menu, then click on Open Model Library File. Select the desired file you wish to open. I will choose RLC_circuit.mo file downloaded earlier from code files. Click on the Open button. Now we will learn about connectors. A connector is a way for one model to exchange information with another model. Use of connectors. Connectors are used in connections, communication, coupling between component and outside world. Next, we will learn to connect classes. For this, I will use RLC_circuit file which we opened earlier. RLC_circuit is a Modelica package containing different classes. Let's expand the package. Here we can see various classes, namely ground, voltage source, resistor, capacitor, and inductor, and also a connector named pin. We will learn more about classes and connectors in upcoming tutorials in this series. This package also contains a circuit class. Double-click on the circuit file and go to the text view. Here we can see that the class does not contain any code. Now go to diagram view. Let us place all the blocks or components in the grid area. Then we will connect them. Click on resistor and drag and drop it into the grid space. We get a message, enter component name. In the name field, enter the component name as R and click OK. Click on inductor. Drag and drop it into the grid space and place it next to the resistor. Enter the component name as L and click OK. Click on capacitor. Drag and drop it into the grid space and place it next to the inductor. Enter the component name as C and click OK. Next, click on voltage source and drag and drop it into the grid space. Place it above the R, L and C which are placed in series. Enter the component name as AC voltage. Note that please do not put any space in the component name field. It will give translation error at the time of simulation. Now click OK. Next, click on ground and drag and drop it into the grid space. Place it below the R, L and C components in series. Enter the component name as Z and click OK. Now we have all the required components to construct the RLC circuit in series. Let's connect these components. Hover the mouse to the left part of component. A pop-up RLC_circuit.pin appears. This represents positive pin. Similarly, the right part of component shows a pop-up as RLC_circuit.pin. This represents negative pin. Place the cursor over the negative pin of the resistor. We can see a plus sign when the cursor is placed over N pin. Click on the pin, hold and drag it to the P pin of the inductor. Click on inductor's P pin and then release the cursor. Next, we will connect N pin of the inductor with the P pin of the capacitor. Click on the N pin of the inductor, hold and drag it to the P pin of the capacitor. Click on the P pin of the capacitor. Now we have connected the resistor, inductor and capacitor in series. Next step is to provide the voltage source. Click on the P pin of the resistor. Hold and drag it to the P pin of the voltage source. Similarly, we will connect the N pin of the capacitor with the N pin of the voltage source. Click on the N pin of the capacitor, hold and drag it to the N pin of the voltage source. Click on the N pin and release the cursor. Next step is to ground the circuit. Click on the N pin of the voltage source, hold and drag it to the ground. Note that ground has got only one pin, which is the P pin. Click on it and release the cursor. Now the circuit is complete. Pause the tutorial and check that your circuit looks like mine. Press Ctrl S to save the class. Now we will check for the correctness of the class. Click on Check All Models button. Observe the messages browser. It shows the number of equations and the number of variables. Model will be ready to simulate if both of them are equal. Click on the Simulate button. A new window appears. This output window displays the success message. Expand R and click on IR to get the plot between IR and time. We will learn about equations and variables in the upcoming tutorials. That's all for this tutorial. Let's summarize. In this tutorial, we have learned to create a new class, open an existing class, connect different classes, build a model, and simulate the model. As an assignment, construct a RLC circuit where resistor, inductor, and capacitor are in parallel connection. Use the same classes and connector available in RLC_circuit package This is the diagram of the circuit which needs to be constructed. Watch the video available at the following link. It summarizes the spoken tutorial project. The spoken tutorial project team conduct workshops using spoken tutorial, give certificates to those who pass an online test. For more details, please write to us. Please post your time queries in this forum. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificates for those who do this. For more details, please visit this site. The FOSSEE team helps migrate commercial simulator labs to OpenModelica. We give honorarium and certificates for those who do this. For more details, please visit this site. Spoken Tutorial and FOSSEE projects are funded by NMEICT, MHRD, Government of India. This tutorial is contributed by Kaushik Datta and Priyam Nayak. Thank you for joining.